The purpose of this video is to help parents work with Scarlett on divisibility rules. This first one I'm going to walk through is a divisible by 3 question. All of the rules are on this divisibility rules cheat sheet, and I don't need Scarlett to have to go back and reread it every time. You can give her, like, if she doesn't remember what the rule for 3 is, you can remind her. So the rule for 3 is adding. And I would ask her, okay, so we got to add these digits together. I might write it out. And if it's something like this, I would ask her to look for pairs that make 10. So I might point out, oh, what do 8 and 2 make? Or I might say, do you see 2 numbers that add nicely to 10? In this case, there's only 3 numbers and they're low, and like she'll be able to do this quickly in her head. But for more complicated numbers, you could use the strategy that I just described. So we find out this is 10 plus 8 is 18. So then I say, Scarlett, what are we supposed to do with this number 18? She might say, I don't remember. Oh, okay. Well, we're trying to figure out, is this big number divisible by 3? And so we've figured out, oh, we know all of these numbers add to 18. We need to know, does 18 divide by 3 evenly or not? So to do that, we come over to our multiplication table. Here we are, we have 3, because we're starting out, we're trying to divide by 3. We need to see, is 18 a multiple of 3? So then I would trace this with her and go, oh, here it is. What does that mean about this number? And she would say, oh, well, 18 is divisible by 3, and it makes 6. And then I would say, yes, that's true. What does that mean about this big number? Does that mean that this number is also divisible by 3? Oops. Or does it mean it's not divisible by 3? And the answer is yes, it's divisible by 3. That is the rule for 3s. It's the same thing for 9s. And perfect, we actually got a 9 problem. So for this one, I might ask, what is the rule for 9s? And she might say, I don't know. And I say, okay, the rule for 9s is just like the rule for 3. And we just did the rule for 3. Do you remember what that is? And she might say, oh yeah, adding. And I would say, okay, yes, here we go. We're adding numbers. What does this equal? These are all low, so I wouldn't ask her to try to combine to make a number that equals 10. But she might say 7 plus 1 is 8, 6 plus 1 is 7, 7 plus 8 is 15. Okay, great. So now, Scarlett, what am I supposed to do with this number 15? Oh, I don't remember. Okay, well, we're trying to find out if this big number is divisible by 9, and now we have the number 15. We need to see, does 9 go into 15 evenly? Then we would jump over to here, and here's my 9. And I would go, okay, it goes 9, 18. Does 15 come up evenly, or did we skip it? Oh, we skipped it. So what does that mean? Is this number divisible by 9 or not? And she would say, no, it's not. Okay, what does that mean for this big number? And then she would say, no, it's not divisible. So that's how 9s work. For the 6s, 6 is tricky because you have to do 2 rules. So I would ask her, do you remember what the rule for 6 is? And she would probably say, I don't remember. And then I would say, okay, 6, what are the 2 numbers that multiply to equal 6? And then I would help her get to 2 and 3. 2 and 3 multiply together to equal 6. If 2 and 3 go into whatever the big number is, then 6 also will. So we have to check for the 2's. The first thing to check for the 2 is how? What's the rule for 2? And then she would say, oh, even. It has to be even. And then I ask, okay, is this big number even? And then she would say, no. And then I say, how come? And she would say, oh, because there's not an even number in the ones place. And she'll probably need reminders for this part, but I really want her logic to be rock solid, because as you venture into ratios, if this part's rickety, it makes ratios really tough. So for the sake of this problem, I'm going to pretend that it is even. So I'm going to pretend this is a 2. So I might say, oh yeah, that works. In real life, I would say, you're right, it's not even, which means 2 doesn't go into it. Does that mean 6 will or 6 won't go into this? Oh, 6 won't go into it. That's true. How come? Well, because 2 and 3 both need to go into this big number for 6 to also go into this big number. You can see how 6 is the most complicated. This is the most complicated one. Okay, so I'm going to pretend that this ends in a 2. So let's say, oh, yes, it is even. Okay, now we have to check 3. What's the rule for 3? Oh, I don't remember. Okay, what do you think? Try to think back to a couple problems we did. And if she really doesn't know, then say you add them. And then I would write out the numbers. And she could write the numbers out too, but it's a little bit more fun if you're adult. We'll write out the numbers. And then I'm pretending it ends in a 2 for the sake of this problem. Okay, now I will say, Scarlett, do you see any 2 numbers that add nicely to 10? And she might go, well, it's 7 and 3. Yeah, 7 and 3, that makes 10. And then because there's so many numbers, I'm practicing crossing them off. Okay, do you see any more numbers that add up to 10? Oh, well, 2 and 2 make 4, and 1 makes 5, plus this other 5 is 10. That's true. Did I get all of the digits? Yes. Okay, great. What do I have total? I have 20. Okay, now what are we supposed to do with this 20? I would ask her, and she might say, I don't remember. And then I say, oh, well, we're trying to do 6. We got the 2. We're trying to figure out the 3. So we're trying to figure out the 3. We added all these numbers together. We're trying to see, is this number divisible by, and then hopefully she says 3. And I say, yes. Now we go to our table. Here is our 3. We're going to check, is 20 in 3? Is 20 a multiple of 3? And then I would track it with her. Oh, here's where 20 should be. Does 3 go into 20 evenly? No, she says. Okay, so what does that mean for this? 3 does not go into this big number. You're right. It didn't work. Let me go back here. 3 didn't work for this big number. So what does that mean for the number 6? Does 6 go into that big number or does it not? And she would say, it doesn't. And I would say, you're right. The answer is no. So that is 6s, 3s, and 9s. 9s is the same as 3s. Just when you go to the table, you would look at 9s, multiples of 9s, not multiples of 3. Okay, the last set of problems that I want to show you is 4s and 8s because it has to do with using table and using short division. So here, she'll probably say something like, oh no, 4 doesn't go into it because it's not even. And actually, she's right in this problem that if it isn't an even number, then 4 and or 8 will not go into it. But that isn't the exact criteria we need because there are even numbers that 4 can't go into. So we actually have to do the whole process. She actually has gotten to the place of, oh, right, 4 is the last 2 digits. And she also remembers 8 is the last 3 digits. She does remember that often. So in this example, I would say, okay, we have 7103. You told me we have to look at the last 2 digits. What are the last 2 digits? And then she would say 3. Yeah, 03. Huh. Does 4 go into that or does it not? No, she would say. Then I say, you're right. That means the answer is no. Let's say that actually, in real life, it's 7148. So then I would say, okay, what are the last 2 digits of this number? And she would say 48. I say, yes, we're going to do short division. There's also a way you can use the table, which I will show you. So I would say, and here I would say, Scarlett, how do you say this out loud? She'll probably say 4 divided by 48. And then I would say, oh, that is totally true if I have it like this. If I wrote it like this, that would be 4 divided by 48. We have something funky here where you say something on the inside. You can remind, she and I have talked about this. So you can say, oh, this is that weird thing. If you see this squiggly line, then it means, oh, we talk about the inside first. So then I would ask her to say, oh yeah, it's 48 divided by 4. Or 4 goes into 48 how many times? So I'm working with having her say stuff out loud because I really want her thinking in math to be pretty solid. And I'm also working with helping her feel right. So here we are. Short division is, how many times does 4 go into 4? I would say, she says 1. I say, yep. How many is left over? None. Okay. How about how many times does 4 go into 8? 2, she says. Okay, does that go in evenly or is there stuff left over? She would say, oh, that goes in evenly. Okay, great. So 4 went into 48 12 times. Here's another learning opportunity, you guys. I would say, Scarlett, tell me a sentence. It can be 4 goes into 48 12 times, 12 goes into 48 4 times, 4 times 12 is 48, or 12 times 4 is 48. Any of those renditions, I want her to practice understanding the relationships between these numbers. So then I would say, okay, so what does that mean for this big problem? And then she might say, yes. And then I'm pretending this is the number for the big problem. And then I would say, okay, I agree it is yes. What's the reason it's yes? And the answer is, oh, because the last 2 digits are divisible by 4 evenly. Okay, that is the 4. Similarly, we have 8. So for eighths, it's the same thing except it's the last 3 digits. It would be something like, oh, I don't have to write it all. I would say, what are the last 3 digits? And she would go, oh, 528. Great. I have 528. Now I need to figure out how much does 8 go into that. Scarlett, how do I say this? 8 divided by 528. That is close. That would be if I was reading it in this format. I would read left to right in this format, but when it's in this format, it's different. And then she'd go, oh, right, it's 528 divided by 8. Yes. Or 8 goes into 528. Can you say that? Yes, 8 goes into 528. So then I would say, does 8 go into 5? No, she would say, okay, well now we need to look at, does 8 go into 52? Let's go look at our chart. Here we have 8. Now we need to bump over, where's 52? Where's 52? Oh, here, it's in here somewhere. So Scarlett, how many times does 8 go into 52 evenly? Well, it's 6 times. So then this would be a 6. And this part that I'm walking through right now is really tricky, so you need to go slow with her. Okay, 8 goes into 52 6 times. What number did that get me to, Scarlett? Oh, it got you to 48. Okay, how many do I have left over to get to the number 52? Oh, well, 48, 49, 50, 51, 52. There's 4 left over. You're right. That means that the 4 goes here, and this number becomes 48. Now I ask, how many times does 8 go into 48? Let's look at our table. Oh, I'm actually on it. How many times is that, Scarlett? It's 6. Yes. Okay, Scarlett, tell me a sentence with these numbers, and I'll write it a little bit nicer so you can see all of the numbers. And again, the sentence would be 66 goes into 528 8 times. 8 goes into 528 66 times. Or she could use divided by language or multiplication. But I want her to practice seeing all of the relationships in that number. So then I ask, oh, okay, well, the point of this is we're trying to figure out this big number is divisible by 8. And we just found out that this number is divisible by 8. So what does that mean for this big number? Yes, it's divisible by 8. That about covers it. So we did 3s and 9s. We did 6s. These are adding. 6s are, does 2 and 3 go into it? 4s and 8s are the last 2 and the last 3. Instead of doing short division, we can, if it's something like the previous problem where we were looking at, I think if it was like 7 going into 56 or something like that, then you can come over here, just like we had before, and go, oh, is that number one of the multiples of our number here? So you don't necessarily have to do short division. If the number is small enough, we can't do it with 528, but we could do it with the one that we did right before it, where we look at the table. Okay, that covers it.